Otherwise, it's going to be super hard to get in here. Now, remember the keying. The keying is important. You want that little notch or that little groove to point towards your power source. Why does it say I'm like almost out of power? Maybe it's this guy. We'll see how that goes. Yeah, my laptop's charging, but it just seems to not be happy. That would stink if we shut down mid-class, midstream. All right, we're going to power through this. Now, let's start putting things together. I'm going to describe some of these parts. These other parts that you have are capacitors. These are ceramic caps. Caps for short for capacitors. There's also electrolytic, and we're not using those. Those are polarized. These are not polarized, so you could put them in any direction you want, but there's two different capacitors. You want the one with the text 106. All right, that's the one you want. You want to go find the one that says 106 and use that one. All right, this one says 223. Well, I don't want that, and we have two. Process of elimination. Now look at where that 106 is. It is in the ground on the bottom rail, and then it's kind of on pin 2. Now that I've taught you the pin numbers, I can reference them, and then you know what I'm saying. So pin 2, remember, this is 1, that's pin 2. Pin 2. So go from pin 2 to ground. I would start with the ground, because it's just, ground is ground. It's got to be there. And then wherever that other part of that lead fits, put it in there. All right. Next one. Let's do some other wiring, because that's really simple. And you can see the color-coded wire. Try to find the one that matches, so this way it's easier for you. So we've got a red one that is on pin 6 that goes to the potentiometer. So what I'm going to do is I'm going to grab the red one. I'm going to straighten it out. It's a little bent from the other project I did. I'll fix it. All right. And it goes from pin 6, right here, but it's like one up, one away, because we got another wire that needs to go in there. And then keep it straight and go straight down to the other side wherever it reaches. All right? And it should look like that. Pin 6 to here. Now that I know the length of my wire and how far it goes, I'm going to grab my fun little potentiometer. And because I know that wire goes to the middle pin of the potentiometer, all right, they've got 3 pins. We're going to use 2. I'm going to line it up. And, I was a little off. And put it in. So now I know where my 555 timer belongs, my ceramic 106 cap goes. I've got a wire leaving my 555 timer, to my potentiometer. And we can keep building this out. Then grab one of the orange wires, and that goes to the other side of the potentiometer, which we also like to call pot. Not the stuff you think I'm talking about. And then that goes to pin 7. That goes there. All right. Let's keep wiring up. We got a blue one. The blue one goes between pin 8 and what looks like, was that 3 volts? Yes, 3 volts. So that is going to be the power driven to the 555 timer. So this thing is taking 3 volts or 3.3 volts. All right. That one's done. Let's do the ground. So we got a black wire. That, remember, if I said before, pin 1 is ground. So we start at the ground. It's just easier. And then take it to pin 1. Remember, it could be anywhere on that rail. They're all connected downward like that. Everybody following along? Or you kind of went your own way? There is no wrong way. Well, let me say it again. There is no right way to put it together, but there's definitely a wrong way. All right, so we got a yellow and a greeny guy here. I'm going to use the greeny guy, even though it looks like, I don't know what color that is. But that connects positive to 4. So I'm going to go positive to 4, pin 4. Okay, somebody doesn't want to cooperate, and you force it in. Good. Now we can do other components. I like to build up. I like to do the things that are kind of low and then kind of get a little higher because the bigger things are in the way. Like if you put the big things in first, like resistors sticking up and LEDs, then it's harder to maneuver, and you got to keep moving them out of the way. Are you good over there? Keeping up? Okay, you look like you're doing great. I'm going to do this other wire here. So on this particular circuit, pins 2 and 6 short one another. So to close off the whole circuit with the timer, you just kind of create like a short or a jump. So you just take one of the orange ones, kind of bend it a little bit, put one end in pin 2. Come on. There it goes. And then go to 6, which is where the red is, and put that in. And you kind of get a thing that looks like that. Whew, I don't know why I'm sweating. It's hot in here. Now, we're going to add the other components. So we've got a resistor that's red, brown, yellow. All right. Red, brown, yellow. Nope. That's purple. Oh, it's purple. It's not brown. Oh, in the book, purple looks almost like brown. I forgot to tell you. So on your resistor, it looks very purple. But the other, in the book, for some reason with the printing, it looks a little more brown. You want to put that guy. So if we go back to, what is it? Purple is 7, or violet, excuse me. Someone's going to yell. Actually, it's yellow, which is 4. Violet is 7. And then red, which you note is the power of 2. So that would be 4.7K resistor. That goes up here. So we put one on 8 over here, and then one on 7. All right. So we put a resistor between pins 7 and 8. All right, good. Do the other resistor. So that one's brown. I don't know what color this is. Brown, purple, red. Blue. No, it's blue. So brown is 1. Blue is 6, and red is to the power of 2, 10 to the power of 2. So that equals, I don't remember. Oh, it's a 1K resistor. I read it backwards. Back to that 1K resistor. There it is. Yes. So we take one end of it and put it at pin 3. 1, 2, 3. And then the other end, doesn't really matter where it goes because we're going to connect our green LED to the other end. So one end goes into negative and one goes to positive. Short end is negative. Long end is positive. The positive is the other end of the resistor. The negative is on that blue minus sign rail. And I look like I am completely wired up. Who is with me? You're done?
Yeah, we're still working on the 106. Is that this one?
I look at them both. The 106 is hard to read, but they both, one's a 223 and one's a 106. So if you could read the 223, then you know the other's 106. Yeah, it's hard. The phone's a good cheat. You guys are not going to believe this. I just remembered a little piece of Hack for Kids trivia. Of all the Hack for Kids we've put on, this is the first workshop I've ever taught. I've never taught anything other than like presentations. Like I've kind of done some other stuff, but this is like, I guess, the real first workshop I've ever taught. So that's kind of cool. Yay. Yay us. All right. I'm feeling brave. I'm gonna start this on 3 volts. Make sure you are on 3 volts. And I could change, yeah, the speed of it. Nice. But it's got like that 1K resistor keeps kind of bringing me down here. So I'm going to pop it up. Whoop. I don't think we need this anymore. So look at that. Look at that. We got a working circuit. And it's like I can play with the speed. I can make it blink really slow. It's almost like a half second. All right. That, it looks like it's always on. Now, I don't know the facts behind this, but I'm going to say it's blinking so fast that our eyes can't pick it up. But some people might say, no, it's always on. You've given it so much electricity, it just stays on. But I just think our brains can't perceive that level of speed because the timer is working. You know, the timer is blinking so fast, we can't perceive it.
Try slow-mo. Do a slow-mo.
I could do a slow-mo. In edit, I'm in post. We'll edit that in post. So now I'm going to change it back. It looks like it's solid, but now we got a nice, speedy little blink there. Who's with me? You got to blink it? Oh, look at that bad boy. Let me see you turn your potentiometer. Oh, it's working perfectly. Good job. And Dad didn't help you. Right? Not at all. You got a future in politics, kid. I'm just kidding. All right. Take a look at the Twitch really quick. We're live. Excellent quality. 1 solid viewer. We appreciate you. You complete me. Oh, there's an error with the player. No. And a new follower. Bitrate's good. I liked it before when Twitch had the desktop player. Now with the whole thing on the web, it gets janky for me. All right. Let's go back to OBS. Aye. So we got a blinky going. I'm going to turn it off. I'm going to start pulling these other things out. Oh. Yeah, when your LED is really low, switch it to 5. We're almost done. Hang in there. I know you guys want to go back to the CTF and earn some more points. Are you guys putting your points in? You guys all look confused as to what I'm talking about.
Put a couple in, not all.
All right. 3:30. It shuts down. It's on a timer. Oh, look at this mess. All right. It's good enough. All right. My header's on. Okay, let's make the next circuit. The next circuit is the one for the servo motor. Servo motors are fun. They are a lot of fun. Now, you could leave some of these parts in. You're going to leave your 555 timer in. But literally almost everything other than a couple jumper wires comes out. And you're swapping your 106 cap for the 223 cap. So the first thing I did when I was making this was I'm swapping caps. Sorry for the disturbance. That was my child. He is trained to know to see on air means time to go back to whatever you're doing. All right. Another interesting thing is we got this resistor here. The 1K is coming out, and it's getting replaced with a 3-prong, which is on pins 3 and 4. Is that 3 and 4? Nope, that's 3 and 4. All right, 3 and 4. Let's see, we got 2 on power. So now we need to take another one of these preformed wires and put that on ground. I don't think it's going to reach. I might have to just swap these out. And put that on power here, and I don't like it when they don't cooperate. That's good. All right, so we've got this guy getting power and this guy handling the ground for the servo, because that's where we're going to connect the servo. And these purple lines here in the booklet mean, let me see here, purple lines means the purple on this cable is where it goes. Well, there's no purple wire. Is there? Yeah, it's purple. The light's not so good here. Now, I got this side done. I'm going to move to this side. And now instead of having this wire here, it's going to come out and it's going to move over there. But I'm going to wait for a second. And I'm going to replace that with a resistor. And that resistor is, oh God, is that red, orange, red, black, orange, or orange, black, orange? Let's see. Resistor. Oh, right here. Yep, red, black. Is that purple or black? It's black. Red, black, orange. So red is 2, black is 0, orange is 10 to the power of 3. So 20 times 2 to the power of 3 is 20K. Use a 20K resistor. Now, one end goes on 8, pin 8. If I can grab it, I'm going to flip this guy over. Right here, pin 8, and then down here. Well, line it up. There we go. That goes there. This comes out. Oh, in the last circuit, dumb me, what I wanted you to test, I completely forgot, is taking out the green LED, so you could do this at home. Take out the green LED, replace it with the self-flashing LED, and see if you can control it with the potentiometer and your 555 timer. See if that works. Now, we got this guy here. We got our 20K resistor. We've got this wire, and now we need to use a diode. So the diode is this one that's black with a little gray or silver stripe. This is also polarized. So the stripe tells you where negative goes, okay? All right, so this goes like here. What pin is that? 6. There's 6 right here. And then over here. It's kind of a weird thing going on. Just do that. Just kind of preserve. Actually, let me put it down to 1. Is it 6 or 7? 6, pin 6. 1 here, and 1 there. All right, good. Now we need another resistor, and that resistor is 1 meg. It's a lot. So it's a brown, a black, and a green. Brown, black is 10. Green, 10 to the power of 5. 1 million, or 1 meg. You guys are used to meg versus million. Here it is. Take that and just kind of have it run in parallel with that diode. So they both go in the same holes on the same rails. That's weird. All right. I think I got one more wire, which is this red wire right here. So this red wire will go next to this guy, the diode, right here, which is pin 7 on the timer. And then we want this all to come together. And they got a nice little wavy line there, but in reality I can't do that, so I'm going to bend it. I use the back of my tweezers to bend it. And let's get it in there. So you get a nice happy family. Boom. Check your connections. Make sure you didn't knock anything out. Whoo. We got a bunch of stuff going on here. We got a 1 meg resistor. We got our diode. We got our 555 timer. We got a 20K resistor. We got a potentiometer wired up. We got a capacitor and our jumper, our header pin. So when you have everything set on your circuit, then oh, it's working already. You guys are fast. Plug it in. All right, we got this. I'm going to give it power. And I ain't getting anything. Let me go down to 3. I noticed when I was actually testing all this, it seemed to work better with 3 volts than 5. With 5, it would have too much power and it gets stuck. And I'm not getting anything. What did I do wrong? On there. Oh, I put it in the wrong hole. All right, here we go. There it is. The other thing is when you notice, like, if you go too far in one direction, ooh, yeah, 3.3 volts is better. 5, it seems like the servos inside are slipping, but I'm not getting any movement. I think this is just not happy over here. All right, let's try it this way. I feel vibration, but it's not moving. Maybe I broke it when I was setting it up. But you got your servo. Yeah, you can just sit there and fidget all day, twisting your potentiometer and making it work. Is it working? I saw a face. You feel a buzz? Put it down at 3.3 volts because sometimes the 5 is too high. It might be too much power. And then turn it. Is it working? Loosen up your screw. Here's another one. You shouldn't throw screwdrivers, kids. It's dangerous. Meanwhile, I just threw a screwdriver. Is yours working over there? Yeah, great. Yours? Jack, Owen, Walter. What was your name, big guy?
Marcus.
That's correct. Very good, Marcus. I'm glad you remembered your name. Parents like that joke more than the kids. I know. Well, when you were a baby, you didn't say your name? What'd you say first? Mama or Dada? All my kids said Dada. That's what I tell my wife, but she doesn't believe me. That doesn't go very far in the household. But that really kind of concludes everything. So you guys built your circuits. You went through all these different parts. If something didn't work, just check sometimes. I've noticed the components don't sit very well in the breadboard. They might be a little loose. Maybe move them over or something to get them connected better. Sometimes you could take tweezers and literally use the tweezers to create a connection in between, and that helps as well. But I hope you guys had fun. Did you guys have fun? Was this good? Yeah. They can't hear you on the stream.
Yeah.
Yeah, that was a mummy. Yeah. All right. No, you guys are great. I'm glad you had fun. I'd like to do this again in the future. We might do another one. Either for my last. Something was backwards, right?
Yeah, the 3 pins from the servo motor would turn it around and I started working.
Oh, yeah, because you didn't send power to it the